Hello everyone, welcome to Coders Camp. So we are today at the sixth day of May LeetCode challenge, and the problem we are going to cover is convert sorted list to binary search tree. So the input given here is a head of a linked list, and we have to return the height balanced binary search tree as our output. So let's understand this problem with an example. So here is our given input where the numbers are in ascending order, and if we are forming the height balanced binary search tree, then 0 would be our root node and goes -3 as the left child and then -10 as its left child, and here 9 as its right child and 5 as its left child of 9, and this is going to be our output. So before getting into the concept of this problem, let's understand what is a height balanced binary tree and binary search tree. So the given example here is a height balanced tree. A height balanced tree is nothing but the all depth of each subtree are going to be equal or differ only by one node. For example, here the depth of the node 2 is 1 and depth of the node 3 is 0. So by the definition of height balanced binary tree, the difference can be almost 1. If it goes more than 1, then it is not a height balanced tree. For example, if we are adding one more node to our node 4, then it is not a height balanced tree because the depth of 2 is going to become 2 and depth of 3 is still 0. So in this case, it is not going to be a height balanced tree. So most of you understand what is a binary search tree. So here is the quick definition. A binary search tree follows this rule, that is the left nodes to the root of the tree is going to be having the lesser values than the root, and the right nodes are going to have the higher values than the root. So now getting back to our example. So here is our given linked list example. So now by the definition of binary search tree and height balanced binary tree, our binary tree first should have equal number of nodes in both left and right side. Same way, by the definition of binary search tree, the root node should have the higher value and the left node should have lesser and the right node should have higher values. So here the advantage given is the list is sorted. So in this case, it is very easy to find our root node. Since both left and right subtrees should have equal number of nodes, the middle node should be the root node, so that we will have equal number of left child and equal number of right child. Also, it satisfies the condition the values in the left side are the lesser values and the values in the right side are greater values. So here the idea is to find the middle of the linked list and have that as our root node. So 0 is our root node here. So once this is done, we're gonna construct a left subtree and attach that to our left child of our root. Same way, we are going to construct a right subtree and attach that as our right node to the root. So here, coming to our first half of the list, that is -10, 3 and -2. Here we have to find again the root node of our left subtree. The root node will be in the middle. So -3 is going to be the head of our left subtrees. -10 is the lesser value, so it goes in the left side. And -2 is the greater value than the root node, so it goes in the right side. So this is again a binary tree which is going to be the left child of our root node 0. Same way, coming back to our right side, we are again going to find the middle node and going to be the root of the right subtree. And once this is done, we're going to search for the lesser value, which is obviously going to be in the left side, and put that in our as our left child of our root node. And the higher value goes to the right side of our root node, and overall this forms a height balanced binary search tree. Let me clear this. So you must be getting an idea by now. So our task is to find the middle of the linked list and then have that as our root node and further proceed constructing our left subtree and right subtree. So since we are going to perform the same operation again and again, we are going to go for a recursive solution. So our recursive solution going to find the middle of the passed range every time and keep that as a root node and the lesser value to the left side and higher value to the right side. So if we are having an sorted array as our input instead of our linked list, it is going to be another problem which is already we have seen in LeetCode, that is form binary search tree from a sorted array. So it is very easy to approach this problem in the same way by converting the given linked list to an array and approaching with the same logic we have used in that problem, because it is easier for us to access the middle element or left index or right index in an array. You can go for that approach because it is very easy, but here we are going to see how we are going to approach this problem as a linked list. So in array it is very easy for us to find the middle element just by using the index of the array, and easy to find the left and right element. But in linked list, how do we find the middle element and pass the range to our recursive function? As always we do for linked list problems, we are going to use two pointer technique to find the middle element and the last element of a given sorted linked list. So here we are going to have two pointers. Let blue is the slow pointer and green is the fast pointer. So slow pointer moves one node at a time and fast pointer moves two nodes at a time. We are going to iterate these two pointers till the fast pointer reaches the end of the linked list, so that our slow pointer will be exactly at the middle. So by using this technique, we found our middle value. Now we are going to set the middle value as our root node, and we are going to pass the range from head to slow pointer to our recursive function. The same way from slow.next to tail of the linked list, again to the same recursive function in order to again find the middle. So once we pass this, it is going to find the middle and again pass the rest of the linked list to the same function. Same way, once it picked the middle of the linked list, it is going to assign the right and left children and pass on to the remaining values to the again recursive function and assign the respective values and form the tree and return the output. So hope you're understanding this solution. This is going to work in big O of n time complexity as we are going to iterate it recursively. So let's go to code now. So here, getting back to our problem, we are going to get the help of a helper method. So first let's check the basic condition. If our head is null, then return null. Otherwise we are going to call a helper method. Let's say construct tree. We are going to pass head of the linked list and null, which is actually pointing at the tail of the linked list. So let's spend some time in writing this construct tree method. So if you see the implementation of tree here, they have implemented the class tree node and they have assigned the values left, right and where. So I'm going to return a tree node as that is what the output needed. So as we are going to call the same function recursively for the range head to tail. And let's declare two pointers, slow and fast. So I'm going to iterate my slow pointer by one node at a time and fast pointer by two nodes at a time till our fast pointer reaches the end of the linked list. So since our code is going to call it recursively, we are not checking whether fast is not equal to null or fast.next is not equal to null. Since it is a recursive solution and we are passing the range, we iterate it till it reaches the tail we passed in this function. So yes, now our pointers will be exactly at the middle and last of the linked list. So now our middle node will be the root node. So assign the root value as the slow pointer's value. Then root.left is going to be again calling the same function construct tree from the range head to slow. Same way root.left is right is going to call the same function slow.next to tail. And finally return the root as a result. So yes, this is it. Let's run and try. Yes, so let's submit. Yes, the solution is accepted and runs in 0 milliseconds. So thanks for watching the video. If you like the video, hit like, subscribe and let me know in comments. Thank you.